Hello, welcome back. So let's continue where we left off. We said we're going to enable clock access to GPIO A. This is similar to what we did in our LED driver. Over here, we had the symbolic name here that set bit 0 in a 32-bit register to 1. So that's what this means, set bit 0 to 1. So I'm going to copy that, bring that over here. And what we did is we took the symbolic name and then we performed an OR operation with this symbolic value, this symbolic name which represents this value, with the current content of the UART, with the current content, I should say, of the AHB1 enable register, because we realized that the AHB1 enable register is responsible for enabling clock access to GPIO A. So I'll bring this as well from here. And this is what we did. This is step number 1, that is complete. Step number 2 here, we said we're going to set PA2 mode to alternate function mode. So to do that then, we need to go to the mode register and see what that implies. Okay, so let's open our documentation. The mode register, because it's a register, we have to go to the reference manual document, which is the document with hundreds of pages. So this is it. I'll double click here and then I'll do Ctrl F over here and then I'll search mode and then R for mode R, mode register. Okay, I wonder why I'm brought here. I'll go back to the top and then search mode R. Okay, so I'll zoom in and it gives me GPIO port mode register. We've seen this register before. We saw how to configure it to set a pin as output pin. This time we want to see how to configure to set a pin as alternate function pin. So we said we're dealing with PA2 for UART TX. So because we're dealing with PA2, we're looking for mode R2. Mode R2 is over here. Mode R2 occupies bit 4 and bit 5. And for alternate function mode, it says the first bit has to be set to 0, the second bit has to be set to 1. So bit 4 has to be set to 0, and then bit 5 has to be set to 1. So let's do that. I'll come over here, and then I'll say GPIO over here, and then I'll say mode R over here, and then we want to set bit number 4. So I'll say bit number 4 over here. So bit number 4, I say 1U over here, 4 over here. We set that to 0, and then bit number 5. So we say GPIO mode R. And then because we want to enable this, we use the OR operator. And then 1U, 5 over here, like this. Okay, next we said we're going to set the alternate function type to AF7. To do that, we need to check the alternate function register. So still over here, I'm going to scroll down. So we are here. I'll zoom in. We have alternate function register low, known as GPIO X AFRL, and the X here represents A, E all the way to H. So GPIO A, GPIO B all the way to GPIO H, something like that. Okay, so over here, when we see there are demarcations after every 4 bit, such that bit 0 through bit 3 is known as AFRL0, and bit 4 to 7 is known as AFRL7, etc. So AFRL0 represents all pin zeros, just like mode R0 represents pin zeros. AFRL1 represents pin 1s. AFRL2 represents pin 2s, AFRL7 represents pin 7s. So then your question is, how about pin 8, 9, 10, etc.? So that is why this version of the register is known as the alternate function register low. For pins from 8 to 15, we use the alternate function register high, which is over here. And over here we have AFRH8 to AFRH15. Okay, so because we are dealing with pin 2, we are interested in AFRL2 over here. And as you can see, this occupies bits number 8 to 11. And we said we would have to set this to AF7 for UART. And AF7 here says it has to be 1110. So bit number 8 to be set to 0, bit number 9 to 0, bit number 10, sorry about that, 1110. So bit number 8 to be set to 1, bit number 9 to 1, bit number 10 to 1, bit number 11 to 0. So when we do that, then PA2 will be set to alternate function UART 2 TX line. So that's what we're going to do. So come over here, and over here I'll say GPIO port A. So if I'm to go with what the document said, I'll say AFR and then I'll say L. However, in the header files, there is no AFRH and AFRL. What there is AFR, like this. And AFR is an array with 2 members. The first member is an array of size 2, or 2 indices. The first index represents AFRL, and the second index represents AFRH. So I'll say index 0 here because we are working with AFRL. So then I'll use the OR operator over here, and we said we start with bit number 8. So shift 1 to position 8 over here like this, and then I can copy and paste this. I'll copy this, so shift to position 8, position 9, position 10, and position 11. However, we said bit number 11 has to be set to 0. We have to disable it. So we disable bit number 11 here, like this. Okay. So once that is done, we are done with the GPIO configuration for our UART pin. Next, we would have to configure the UART module. So we said we start off by enabling clock access to the UART module, and we saw the UART module's bus line the other time. So let's come back to our datasheet document. So I'm going to minimize this. When I jump to page number 15, and I come over here, USAT2 over here, it's connected to the APB1 bus. So we need to go to the APB1 enable register to find the appropriate bit. So I'll go to our reference manual document, and then I'll come to the top here, and then I'll do Ctrl F, and then I'll say APB1 ENR, and then I'll click to jump there. And over here, bit number 17 is called a USAT2 EN, meaning if we set bit number 17 to 1, we enable USAT2. So I'm gonna do that. I'll come over here, I'll say define over here, and then I'll say UART2 EN, and then I'll say shift 1 to position 17, like this. Okay, so once that is done, I can simply copy this and then come over here and then say GPIO, I'll say RCC rather, RCC over here, APB1 enable register. We want to perform an OR operation. Look at that, I've pressed something by mistake, sorry about that. So shift 1 to position 17. So we come back here, RCC APB1 enable register, and then OR operation, like this. So then we've enabled clock access to UART2. Next, we said we're going to set a baud rate. So to set a baud rate, we can either write the value directly, or we can write a function that would configure the baud rate for us. So to do that, I'm going to come down here to develop a static function. I'll say over here static, and then I'll say void, and then I'll say UART. I'll say UART compute baud rate or something. I'll say compute over here. And for those of you who have taken the bare metal course, we've done this before. Compute BD, and this over here. So the baud rate is going to, this function is going to take two arguments, the peripheral clock line and then the desired baud rate. So all of them are of type U_32_T. And I'm going to call this perif clock. Perif CLK, and then UN32_T, I'll call this baud rate. So the baud rate here is the desired baud rate that we want to set it to. Okay, so over here, what we're going to do is, there is an equation to do this. We first take the baud rate. So I'll copy baud rate over here. Sorry about that, my USB disconnected. So I'll say baud rate over here. We say baud rate divided by 2, and then we divide the result by baud rate, and then we add perif clock So we add perif clock over here. This is supposed to be perif clock. Okay, so then once that is done, actually, sorry about that, this is the equation. First baud rate is divided by 2 and then added to the peripheral clock, and then the sum of that we divide by baud rate, and we will return this like this. Okay, so this function here, we go into wrap another function around it that would set the UART baud rate. So over here, I will expose this function by copying its name and bringing it here so that we have access to it above it implementation. So then up here, I'll come over here and have another static function. I'll say static over here, void, and then I'll say UART underscore set baud rate. And this is going to take the same argument over here. Copy this. Like this, and what we're going to do is we're going to write the value into the USAT baud rate register. So I'll say USAT 2BRR for baud rate register, and this over here equals compute UART baud rate, and the two arguments will be the argument passed by the user, perif clock over here, and then the desired baud rate over here. Okay, so then I'm gonna copy this, bring it to the top over here so that we can have access to it. Okay, so once that is done, we're going to use this function. Before we do that, let's define our peripheral clock. So the peripheral clock by default is 16 megahertz. If you've not changed the clock configuration of the microcontroller, we haven't. So the default is 16 megahertz for the STM32 F411 board. And the way to find that, you can find, let's see, let me show you. Let's come to the datasheet document. So I'll do Control F over here, and then I'll say clock startup, something like clock. Let's see, I didn't spell clock properly. Okay, clock and startup. Click over here. Over here it says on reset a 16 megahertz internal RC oscillator selected as default CPU clock. So often the default CPU clock is the same clock to the various buses as well, without, if you've not configured or if you've not changed the configuration of the clock. The default CPU clock is the clock to the various buses. So it says, let's read further. This is 16 megahertz internal RC oscillator, factory trimmed, 1% accuracy, blah blah blah. The application can then select a system clock either. Okay, anyway, so this is how come I know the 16 megahertz. So if you have a different board, then you would want to check by simply searching clock and come into the clock and startup section. Okay, so I'll come over here and then I'll say define over here. I'll say sysfric, system frequency, and a 16 megahertz, meaning 16 million cycles. So I'll say 16, 1, 2, 3, 1, 2, 3, 6 zeros. And then I'll say over here, define APB1 clock, just to make the code more readable. So I'll say APB1 CLK equals system frequency. And once that is done, I'm going to say define over here and then our desired baud rate. So I'll say UART baud rate over here, and that I will say 115200. This is a standard baud rate that most UART deployments use. This and 9600 are the two most common baud rates. So once that is done, we can come over here and call our function set UART. We call our set UART baud rate function. So I'll copy this function here and then come over here, and then the first argument is perif clock. So this over here, following that, the baud rate, this over here, okay. Next, we said we're going to configure the direction. So to configure the direction, we need to go to the UART control register 1. So let's go to our reference manual document. So I'll come over here and then I'll say USAT CR for control register 1. Okay, and then I'll click this over here, and then over here the control register, there is this bit known as RE and this other one known as TE. TE stands for transmitter enable. So when we set this bit number 3 to 1, then we enable the transmitter. So let's create a symbolic name to hold this. So I'll come over here and then I'll say define over here. CR1 is the name of the register. The name of the bit is TE. And then over here is bit number 3, set 1 at position 3. And once that is done, we can write that into the CR1 register. So I'll copy this and I'll take this opportunity to clean everything out of the register. So what I'm going to do is say USAT2 CR1 equals this. I'm not using the OR operator because I want to set everything to 0 except the TE bit. Okay, so that is deliberate. That is different from this. I want to clean everything and set just TE. Set only bit 3 to 1. Okay, so once that is done, we said we're going to enable the UART module. Let's see who enables the UART module. So the UART module here, we have bit number 13 known as UE. Let's find what that means. USAT enable. So when we set this to 1, we enable the UART module. So let's set that. So I'll come over here and then I'll say define CR1, and then the name of the bit is UE and it's bit number 13. Is it? Yeah, like we saw, bit number 13. Yeah. So over here, set 1 to position 13. So I'm going to copy this. Okay. And then I'm going to come down here. And then I'll say USAT2 over here. And then CR1. This time I'm going to use the OR operator. Why is that? Because if I don't use this and I simply do this, it's going to clean the configuration we had here and set everything to 0 apart from bit number 13. But I want to add this to what we already have here, which is bit number 3 set to 1, and now I want to add bit number 13 set to 1. So the OR operator like this. Okay, so this is our UART init function. In the next lesson, we shall develop the UART write function, and this function would be used to transmit data across. So that's all there is. I'll see you. Have a nice day.